the performance synthesis. How do you look at a car handling in terms of vehicle dynamic? Hi, I'm Claude Rouelle, I'm the president of OptimumG. All right guys, today I want to explain to you a little bit our vision at OptimumG of the performance synthesis. You see at the center of this presentation, you have that. You have two things. You have the tire traction lips and the fore traction lips. Understanding the tire, the tire is the only element of the car which is in contact with the ground. It is in these four contact patches that everything is happening in terms of balance, in terms of grip, in terms of control, in terms of stability. And it's not only the answer of the tire, the response of the tire, due to the driver input, cornering, braking, throttle. It's also the way the tire is sending information back to the driver and the ability to driver to feel these forces and moment at the four tires at the same time. So understanding the tire on itself is a big chapter of vehicle dynamics. It's actually the longest chapter of our seminar, or applied vehicle dynamics seminar. Personally, I'm not in love with tire more than I'm with aerodynamic or kinematics or load transfer, but that's the reality. Everything is happening in this four contact patch. Once you understand the contact patch, you need to understand there are 12 causes for the yaw moment. 4FX, braking, acceleration. People are using diff control, torque vectoring with 4 electrical motor, lateral grip, and self-alignment torque. 1, 2, 3 multiplied by 4, an FX, braking acceleration, an FY lateral, a self-aligning torque, multiplied by 4, you have 12 causes of the yaw moment. This, ladies and gentlemen, is the beginning of vehicle dynamics. That's the alpha and omega. That's the beginning and the end of OptimumG seminar also, because what we do is we start to understand the puzzle of everything. So let's look at an example here of what we look at when we look at the tire. All right, slip angle, slip ratio, vertical load sensitivity, camber, pressure, the damping of the tire. A lot of people do not consider the damping of the tire. And unfortunately, the stiffness and the damping of the tire are a function of many things like the speed, the frequency of excitation, the camber, the tire pressure, the tire wear, the vertical load variation. Understanding relaxation length, frequency response, speed. The coefficient of friction is also a function of the speed. Bad news for the aerodynamicist. Yes, the downforce is V-square sensitive. Yeah, but the coefficient of friction decrease not only with the vertical load, but with the speed itself. Some people should know that. All the stiffness, vertical, lateral, longitudinal, and even torsional. Temperature, well, which temperature? The compound temperature, the carcass temperature, the gas temperature, even the rim temperature. All these things has to be understood. And then the physical tire, people who do a finite element of the tire, a model thanks to finite element of the tire, understanding all the part of the tire, all the construction, the tread gauge, the tread pattern, the contact patch. So that's already a big part of understanding of vehicle dynamic. Then you have the masses. You have suspended and non-suspended mass. How much is that mass, magnitude? What's the distribution, weight distribution? The weight distribution is the number one thing you have to look at. The cornering stiffness distribution of tire should be in the same ratio as the weight distribution, roughly, within 1 or 2%. If your weight distribution is 48% on the front, you should have about 48% of the grip on the front, roughly, depending how much understeer gradient you want. You need to know the inertia and the cross inertia. And this is not only for suspended, but also for non-suspended mass. Cross inertia, combination of XX, YY inertia. Kinematics now. If I can share a quick advice to you, in my racing career, I've been confronted a few times to cars who didn't want to react to setup change of spring, anti-roll bar, damper, tire pressure. And then suddenly we change a few pickup points and boom, the car starts to react. Kinematic is very important. Archimedes said, give me a leverage and an application point and I will lift the world. Before you worry about the intensity, try to think about the application point and the direction of the forces. So when you speak about kinematic, wheelbase and track, kingpin inclination, both angle and trail, caster inclination and trail, or what we call the mechanical trail. All the motion ratio of spring, damper, are not necessarily the same. Maybe the axis of the spring and the axis of the damper are not exactly the same. And people do that sometimes on purpose on some passenger car. Anti-roll bar, inertia also. What's the Ackermann? How much do you want to steer the left and the inside and the outside wheel? Where are the initial roll centers and where do they move? They move vertically, they move laterally. Lateral virtual swing axle, so the distance of the instant center with the tire will condition not only the camber variation in heave, but the camber variation in roll. And camber variation in roll, controlling the camber variation in roll is actually much more important than the one in heave. Same way, pitch center. I have a little bit of a problem, to be honest with you, with people who speak about anti-dive and anti-squat. When you look at anti-dive, you look at the front of the car and you ignore the rear. When you look about anti-squat, you look at the rear of the car, you ignore the front. Interestingly, you speak about roll center when you look at the car view from the front, but you don't speak about pitch center when you look at the car view from the side. So if you want to follow the same process, then speak about the anti-squat of the outside wheel view from the front and the anti-lift of the inside wheel view from the front also. And then longitudinal virtual swing axle. In other words, where is the in-center compared to the wheel? And then symmetry or not. There is good reason in a race car to have a car which is asymmetrical. All right, so long for the kinematics. We are going back a little bit to the tire here because we need to understand the ground. Understanding the ground is 50% of the problem of the grip. Micro and micro roughness. What's the material? I mean, is it concrete? Is it asphalt? Are you able to evacuate the water easily? It's a big issue in Formula One these days, racing in the rain. Temperature. The track temperature in the afternoon could be 5 degrees more than the track temperature in the morning, and it's going to be a different grip, a different car. And then, of course, you have the weather, the environment. Think about Zandvoort. We have a few grains of sand going in the little hole that we have between two stones, so the rubber is not going to penetrate the complete gap that you have between two stones. That is going to make a difference. The slope, the banking, think about ovals with banking, IndyCar, NASCAR, and the profile, you know, the crowning of the car, the crest, all these things has to be taken into account. Next step, aerodynamic, understanding the frontal area. How do you measure it? By the way, does the gap between the bottom of the car and the ground, is it part or not of the frontal area? Air density, yes, it's function of the atmospheric pressure and the temperature. In Le Mans, you don't have the same air density during the day and during the night. You have more downforce and unfortunately more drag during the night than during the day. Static and dynamic ride height. What count is the ride height that you have at the entry of turn 6 in the middle of turn 9. So it starts with static ride height, but it's also taking into account the suspension and the tire deflection. Okay, and then these race cars are usually very sensitive to front and rear ride height, but also sensitive to yaw angle, to steering angle. The way with open wheel or with the fender, the way the wheels are steered generate a different flow of the air on the rest of the car, and that has an influence. The roll angle, the speed sensitivity itself, especially when you go to very high speed like Indianapolis, you know, this notion compressive fluid, you're not at Mach, but at 380 kilometers an hour, you start to have this notion a little bit different. And then aeroelasticity, you know, you go on an airplane and you see the wings moving, very different story. So some people, they are not supposed to play on that, depend a little bit the rules and the spirit and the application of the rule. And then active element, DRS for example. All right, and then all the driver input. At the end, unless it's a complete autonomous car, the steering, And what are you speaking about? Steering, brakes, throttle, the smoothness, the speed at which you turn the steering wheel, the amount you turn the steering wheel, the aggression on the steering wheel, the frequency that you have, the integral. These are all KPI. We have a special seminar working on data-driven performance engineering. And believe it or not, in this seminar, as well as our consulting activities, we spend more time helping the driver to get the best of the car and the best of himself. Then we modify the setup of the car. It's still the guy who is giving the input on the car who makes a difference. So steering, brakes and throttle, the smoothness, the speed at which you turn, you push on the throttle, all these things. And then you have all the driver aid like torque vectoring, ESP, diff control, steer-by-wire, traction control, ABS, the clutch also, which gear you are in. So understanding the driver and the input on the vehicle dynamic is very, very important. And then we have one more thing that is important here. Understanding the load transfer in lateral and longitudinal and vertical G. So when you corner, when you brake, and banking, very important, vertical G. Speak about front and rear spring, front and rear anti-roll bar, front and rear damper. Then non-linearity. If you have an aerodynamic car, you're going to need to have a non-linearity that is input in the stiffness of the suspension. Dampers, which are speed, stroke, and also temperature dependent. And then nothing is rigid. You have all the compliance of every single element of the chassis, starting with one compliance that you need, the tire. No deflection, no slip, no grip. The chassis torsion stiffness, the chassis torsion stiffness distribution. You can have a chassis which is 10,000 Newton meter per degree with a first half soft and a second half stiff, or the other way around, with still having 10,000 Newton meter per degree. I guarantee that when you put the car on the track, it's not the same. So we speak about compliance. We speak about the damping, the chassis torsion damping, and all things like the rim, the camber compliance of the wheel, the rim, all the friction compliance, and then bump stop, whether you use bump stop or Belleville washers, for example, preload, clearance, linearity or non-linearity, and the bump stop itself is a damper. The front and rear inerter, which are helping you to control the acceleration, and then the jacking force, understanding the jacking force, how much because of the distribution of the lateral grip on the inside and the outside wheel and the position of the instant center, you can create different jacking force, which means, by the way, that you are not at the right height you think you are, and therefore you are not in the same cell of your aerodynamic bar. So at the end, as I explained to you, the beginning and the end is the tire and the 12 cores of the yaw moment. But during our seminar and in the mind of our engineer when we are doing consulting, we go through all this analysis. The goal is to understand each one of these elements, but also to connect all the dots. OptimumG. It's not about lateral or longitudinal or vertical acceleration. It's not only about roll acceleration, yaw acceleration, or pitch acceleration. It's about a combination of all these things. And that's why we name our company OptimumG, getting the best of all these elements and connecting them together for the symbiosis of the performance of the car. One of the passions that I have is to share my knowledge. And at OptimumG, we have two main seminars that are 4 days, quite intensive, but I think they are worth the money and the time. An applied vehicle dynamics seminar where we go through tires, kinematics, aerodynamics, load transfer, steady state, transient, and basically help you in the concept, simulation, manufacturing, and testing and development of your car. And the other seminar is, okay, your car does exist, you go on the track, how do you analyze the data? It's a data-driven performance engineering. You cannot improve something you don't measure. And without data, you are just another person with an opinion. In this seminar, we will teach you KPI, key performance indicator, how to observe, analyze, measure, compare, and improve both the car and the driver. Beside our seminar, OptimumG has a lot of activities in consulting in the passenger car and the race car industry. We develop software also in tire modeling software, kinematic analysis, lap time simulation, and vehicle dynamic. Leave us a question, leave us a link, and we would love to help you. And if you want to know more, see you in the next video.